Hi, sixth graders. So today we're going to be talking about another topic of ratios called comparing ratios. So up until this point, we have talked just what about ratios are, kind of explain that. And then we've also talked about how to find equivalent ratios, either with a double number line diagram or with a box diagram, or even just kind of thinking about them as equivalent fractions. So what we're going to do today is we're going to take two separate ratios and we're going to compare them. So let's look at this first example. It says Scott is making a snack mix using almonds and raisins. For every 2 cups of almonds in the snack mix, there are 3 cups of raisins. So what's the ratio of almonds to raisins? Well, it is 2, and I'll highlight this, 2, 2, 3. That's for Scott's snack mix. Now, Ariel is making a snack mix that has 3 cups of almonds for every 5 cups of sunflower seeds. So what is Ariel's snack mix ratio? It is 3 to 5. So again, that is 3 cups of almonds for 5 cups of sunflower seeds. So it says if Scott and Ariel each use 6 cups of almonds to make a batch of snack mix, who would make the larger batch? Now, in this case, when it says larger batch, we are pretty much going to use the ratio to find combined who has the greatest number of cups of almonds and cups of whether it's raisins or sunflower seeds. So in order to do that, we are going to use addition at the very end to help us out. So keep that in mind. So what we're going to do is we're going to treat both of these tables just like a double number line. So all we're going to do is just skip count this ratio till we get to the very end. So 2, 4, 6, 8, 10. And same thing with raisins, skip count 3, 6, 9, 12, 15. Now, we can't compare anything yet because we haven't done Ariel's, but we're looking for 6 cups when 6 cups are with almonds. Now, in this example, I see 6 cups here, but I also see 6 cups here. What 6 are we going to use for our comparison? Well, we are going to use that 6 here because the 6 is asking for almonds. So when you also are comparing ratios, guys, you want to make sure you're comparing in the correct category. So since this 6 goes with almonds, I'm going to use that 6 and I'm not going to use that 6. So let's complete the other one so we can actually officially compare. So again, we're going to skip count by 3s, 3, 6, 9, 12, 15, and 5, 10, 15, 20, 25. So in this case, I see this 3, again, it goes with almonds, so that's the correct one. And what we're going to do now, those 6s we're going to use to look at the other part of that ratio. So for Scott's ratio, it's 6 almonds to 9 raisins. So we're going to circle that ratio. So that ratio is 6 to 9. And then for Ariel's snack mix, it's 6 almonds to 10 cups of sunflower seeds. So that ratio is 6 to 10. So the question is, who has the larger batch? Well, when there are 6 cups of almonds, there's 9 of raisins. So what is 6 plus 9? Well, Scott has 15 cups when you combine the 6 and the 9. And then for this example, if there's 6 almonds and 10 cups of sunflower seeds, well, 6 plus 10, Ariel has 16 cups. So if we're asking for who has the larger batch, well, 16 is bigger than 15, so Ariel has the larger batch. So in this case, they actually gave us the number to look for. So we were looking for when there are 6 cups of almonds. So that's why our eye was drawn to that 6. Now in this next example and on your paper, it's not going to give us a specific number. So let's look. It says the ratio of soy sauce to lime juice in a homemade salad dressing is 7 to 6. And they actually already write that ratio first, which is nice. And then the ratio of soy sauce to lime juice in store-bought dressing is 11 to 9. So again, they wrote that ratio 11 to 9. They want to know who has the greater ratio of soy sauce to lime juice. So in this problem, it doesn't say, like in this, when they use 6 cups, it doesn't say when there are 10 ounces of soy sauce, how much lime juice. We just need to find that common number. And again, that common number needs to be in the same category, whether it's both soy sauce or whether it's both lime juice. So let's treat this like a double number line and let's do a little skip counting. We have 7, 14, 21, 28, 35, and then we have 6, 12, 18, 24, 30. And then likewise, let's complete the other table. We have 11, 22, 33, 44, 55. And then we have 9, 18, 27, 36, 45. Now take a look at both of these tables. Do you see any numbers that they have in common at all? So I don't see any numbers they have in common. And if that is the case, you do have to keep going if you don't see any numbers. But when I look at this, I do see 18 to 21 and 18 to 22. So in this case, we're comparing the 18, and we see that the 18 is both in lime juice. So that's what we're looking for. We don't want to compare an 18 in lime juice and an 18 in soy sauce. We want them to be for the same part. So that's good. We're going to use those two ratios. So we have 21 to 18, and then we have 22 to 18. So if we're looking for who has the greater ratio of soy sauce to lime juice, well, 21 plus 18 is smaller than 22 plus 18. So the store-bought dressing has a greater ratio. So that's a really important thing that you need to look at, guys, is that the 18 has to be in the same category. If, for instance, there was an 18 in this category of soy sauce, we couldn't compare that 18 with this 18 because they're in different categories. Now, let's say, for instance, we couldn't find a number they had in common. Well, just like when you're finding common denominators and you don't find a common denominator within the first 5 multiples, you would continue. And in this case, let's say if we did continue our chart, we would get 36 here, and then we would get 42. And in the same instance, you see 36 for lime juice and 36 for lime juice there, and you're comparing it to 42 and 44. And in any ratio that we do compare, it works out the same. 44 to 36 is greater than 42 to 36. So our original statement that we made with the store-bought dressing has the greater ratio of soy sauce and lime juice is correct. So let's look at this next one. It says 1 bouquet of flowers has 3 milkweeds for every 5 tick seeds. So those are different types of flowers. And again, they already wrote that ratio for us. So let's skip count that table. We have 3, 6, 9, 12, 15, 5, 10, 15, 20, 25. And I'm going pretty fast for that because, again, we've been doing this for a little bit. So once the table skip counted, now let's look at our different bouquet. And the different bouquet is 4 tick seeds for 5 canna lilies, which, again, are 2 different types of flowers. So we have 4, we're going to skip count by 4s, 4, 8, 12, 16, 20, 5, 10, 15, 20, 25. So what we're doing now, it says, if both bouquets have 20 tick seeds, which bouquet has more flowers? Now, in this instance, you really need to make sure, this is why it's so important to label, because tick seeds is down here in this ratio, but tick seeds is up here in that ratio. So you're looking for 20 in this row and 20 in this row. So I see right now, I see 20 here for tick seeds, and I see 20 here for tick seeds. So that's the ratio that we're going to use. So what goes with 20 here? Well, 12 milkweeds to 20 tick seeds, and 20 tick seeds to 25 canna lilies. So if we're looking for what ratio or what bouquet has more flowers, 12 to 20 and 20 to 25, well, 20 to 25 or 20 plus 25 is bigger than 12 plus 20. So the bouquet that has more flowers when there are 20 tick seeds is this one right here, Tick Seed and Canna Lily Bouquet. So what you can do, I don't have enough room, just make sure underneath those tables that you write that when they both have 20 tick seeds, the Tick Seed and Canna Lily Bouquet has more flowers. So just keep in mind as you're going through this, guys, all you're really asking yourself is what number do they have the same, and it has to belong to the same category. So the last problem, just like we've been doing, is we are going to compare. So it's two different types of cars, and you're trying to see who has the better miles per gallon. Now, when you are looking into cars and when you maybe eventually buy a car, you're going to want to find the car that has the most miles you can go on as little gallons as possible, because that means that you can save money on gas and things like that. So it says Lauren's car goes 320 miles on 10 gallons. So the ratio, 320 miles for 10 gallons. Melissa's car goes 280 miles on 8 gallons. 280 miles on 8 gallons. In this case, it's not like this soy sauce problem where we're just trying to figure out what number they have in common. They tell us who can drive farther on 40 gallons. So for both of these gallons, we need to get those numbers to 40. Kind of just like a double number line, guys. So for gallons, let's give count 10, 20, 30, 40. Now, you can go to 50, but really, we don't even need that because our ratio is going to be right here. So let's now skip count by 320s. We have 320 plus 320, 640, plus another 320, 960, plus another 320, 1,280. So for Lauren's car, she goes 1,280 miles on 40 gallons. So when we compare with Melissa's, whoever gets the most miles on 40 gallons is going to be the best car or who can drive farther. So now let's do Melissa's car. Let's skip count by 8s to get to 40. 8, 16, 24, 32, 40 exactly. And then let's skip count by 280. So 280 plus 280 is 560. Plus another 280 is 840. Plus another 280 is 1,120. Plus another 280 is 1,400. So in this case, when there are 40 gallons, for Melissa's car, she goes 1,400 miles on 40 gallons. So if we're seeing who can drive farther on 40 gallons, well, who goes the most miles on 40 gallons? And that would be Melissa's, okay? So again, the biggest thing that you need to figure out when you're doing these problems is just what number do they have in common?